Maribor quite long. And since 2007, and before that, you were with Ministry of Environmental and Spatial Planning, Environmental Agency of the Republic of Slovenia. You were working on many national and international projects working with that ministry and part-time working as a faculty of logistics at University of Maribor, even then also. Before that, you worked as senior project manager, SRC.SI. You worked on many projects, EDMS, workflow, help desk, CRM, Lotus platform, input, output, mailing, IS, auditing, and even then also you were a part-time faculty to the same university. From 98 to 99, you were director of the Center for Information System, Chamber of Commerce and Industries of Slovenia. Working as that time you worked as a chief information officer. You worked as general manager from 93 to 98, MARINET, its Market Information Net Limited. Your role was conception and definition and support during the development of the software to be put onto the internet. Information technology advisor with Slovenia, leading bookseller, conception, definition, and complete development of software onto the internet, introduction of a new trademark and activity in the Slovenian market. You were general manager with Abacus Limited. Before that, you were a visiting faculty to Oregon State University Department of Computer Sciences. You worked as a researcher, means you must be pursuing your doctoral and before that and after that. So at Institute Joseph Stephen, you had your different levels of education and mostly you have been at Slovenia only. Your other skills, would like to list some of them as organizational or managerial skills ahead of the company, the department of projects or the project. He is experienced with the scope of the management. Job related skills, if we talk about, as the head of the IT department, the head of the major domestic and international IT projects, holder of several international and IT certification, scope of IT governance, especially IT security and IT investments is well known to him. He's got a good knowledge of project management and ordinary management skill. He carries a good knowledge of process quality management and also communication skills, knowledge of a large number of ISO standards and management frameworks. There are many other skills apart from the credentials that he carries with him. If we talk about the academic interest in terms of teaching and learning, computer science and informatics, risk and investments management in logistics, air pollution and traffic, solar energy management. There's a long list of publications. Jarat, we can understand that you have been into education and profession of education since the last many years, 1991, close to almost 30 years. So with such a profile, Bharat, we take this right to welcome you to the program, this faculty development program on system engineering. Like I introduced you to the group, I would like to introduce the group to you. We have a group of 152 faculty members who are working as teaching faculty in different technical institutions of the country. They represent from every corner of the country, our India. And this group is having an interdisciplinary flavor. So participants are from mechanical, electrical, electronics, computer sciences, metallurgy, materials, whatnot, sciences, pharmacy, management. So you are going to have next 1 hour plus time with this interdisciplinary group. The topic for today is blockchain technology in supply chain. I think I may not be able to speak much about it. I have heard little bit about blockchain technology. I do have some readings on blockchain technology, but I would like to love to be with the participants to learn this blockchain technology in context of supply chain management. With these words, Bharat, you are most welcome to the program on system engineering. And I leave the whole meeting to you, Bharat. Over to you, please.
Sir, just sorry to interrupt you. Sir, my voice is coming?
Do you hear me?
Yes, sir. Yes, yes. Sir, this is
Okay.
Misra. I was just in touch with you in the WhatsApp due to some connectivity issue in the place where I was having. So I was not able to join you in time. So on behalf of our whole mechanical engineering department, I heartily welcome you, sir, that you have provided your precious time for us. So you may start now.
Okay. So first, thank you for this deep introduction. Probably I never had such a deep introduction of myself like you did. Thank you. So today, as you already said, we will talk about blockchain technology in supply chain. And agenda is first, we will talk a little bit about the introduction and background of supply chain or blockchain, then terminology and technical foundations of blockchain technology. I think that if someone wants to use blockchain, or if someone wants to get the most from this technology, they need to understand how this technology works. Then we will talk about why the blockchain is needed, how the blockchain works, and the last one, but not the least one, we will talk about the benefits of blockchain in logistic industry and supply chain. So if you see my presentation, if you hear me, we should start. Do you see? Do you hear me?
Yes, we hear you. We see your presentation. Kindly proceed.
Okay, super. Then we'll go ahead. First, what is very important from this technology is so-called IT point of view, or if you want, not just logistics, but informatics point of view. What is from business perspective, what we need, what we are looking for in IT is so-called CIA. This is confidentiality, integrity, and authority, or not authority, availability of information. This is, as you can see from this circle here, confidentiality is how the information, who can see, who can read, who can change information. Then integrity means that someone should change the information, who has the rule to do this. Otherwise, it's not possible. And availability is that information is here. It's you can use it. It's not destroyed or changed. Change its integrity. This is the most important. And later, at the end, we will talk about this CIA point of view, and this is so-called, as I said, IT point of view. Sorry, because we are not face-to-face. I cannot now ask you if you understand, if you already, if you if you know this point of view, but somehow I will ask you maybe we should spend 20 seconds if this is familiar with you. Are you familiar with this point of view? Anybody?
उसमें और दूसरा ये जो है वो ऑथराइजेशन ऑफ केसी
It was really a lot of voices, so maybe probably you are familiar. Maybe
Is it
not
availability or authority?
Availability and authority.
Yeah, which one is
Yes.
that?
Availability should be here, not authority.
Yeah, not authority. Yeah. Thank you.
Yes. Okay. I made this presentation yesterday at the night, and probably I made a mistake. Sorry. Okay, here is the other point of view. The other story is what is supply chain and what is information flow. As you can see, here here is a model of supply chain, and you can see that in a supply chain, it's really a lot of information flow. Sometimes the value of this information flow is even higher than the goods which are which we are talking about in this business. Sometimes the value of information flow about one food from Africa to Europe, the value is higher than the value of the goods which we are talking about. So here you can see that from the beginning of supply chain to the end of a supply chain, this is a model. Of course, should be different models and so on and so on. But here is one example of a model. We have really a lot of information flows, different information flows. And somehow we spent really a lot of time and a lot of money to work with this information flow. Usually this information flow means these are documents, somehow documents. Okay, let's go ahead. Here is another model of a supply chain. You can see that from different parts, from different elements of a supply chain, all these elements are connected together, and it's pretty the same like what this picture wants to say. Is just another case of the same story. So each element of a supply chain should be connected, not with everybody else, but with a lot of another elements of a supply chain. And people who are familiar with internet or computer networks, you can see here that this picture here is pretty the same like the picture of a internet. Okay, it's some kind of computer network. Okay, and still another story, of course, connected with blockchain technology. Here is today is pretty the same. I checked in the Gartner group and so on, but this picture is pretty good, because it's still today that just a few companies already deployed supply blockchain technology. A lot of business are still not interested about this technology, but a little bit less than a half they are checking this technology, this approach, and a lot of business they have on so-called they have on the radar about this technology. And we also have some about 20% of business which are planning. They don't know exactly when, what is medium or long-term planning, and what is short-term planning. Okay, we know what is this, but the problem is that after this COVID situation, a lot of things changed. We don't know exactly today what's going on with this technology. But somehow, with each technology or in the life in general, we are faced with this curve here. And this curve is maybe it's well-known curve for people from the area of economics and so on. But at the beginning, when the technology is new, we started to check this technology. At the beginning, we are expecting really a lot, and these expectations goes to somehow peak, and then these expectations fall down, and we are faced with another peak. Here, with another peak, the curve should be changed and go up, or sometimes the curve goes down and technology are obsolete, are no more in interest focus, and so on and so on. If you think we are faced with this curve in everyday life, maybe you can imagine that, or maybe you can see this, that if you meet some person in your life at the beginning, you have the expectations of this person is very, very high, usually. Then this expectation goes down, and later these expectations are on the so-called plateau of productivity. So this is not in connection just with blockchain technology, but this curve is in everyday human life presented. Okay? So if you have in mind this this curve, and according to Gartner forecast, we can see that we already went through this peak of blockchain technology. This peak was last year or a year before, and now we goes down because expectations was very high, and if these expectations are not go up and up and up, because you cannot go just up, we are now in probably in this part of the curve we are going down. But later the forecast is that this technology will be on this plateau of productivity. Okay, this is the curve, but here you see these and these and these and these are how many solutions are already implemented. Big solutions in the world will be implemented, and you can see that the number of blockchain solutions will go up every year more and more. This is according to Gartner forecast. And of course, it is also in connection with this medium or long-term planning or short-term planning, how to deploy this technology. Okay, let's go back to technology itself. It's important to know why blockchain technology is good, and it's connected with this CIA. We already talked about this at the beginning. Confidentiality, integrity, and availability of information. If you have something, some kind of connections, this should be networked with one central point, it's very risky. It means that you have here in the middle, usually you have a server, and around are so-called slaves, computers, or in general in life, slaves, and in the middle you have server. This architecture is very risky. Then you have so-called decentralized systems and the full distributed systems. This model is very strong, and the internet itself is based on this distributed approach. Okay. Here you can see if someone switch off the bottom here in the center, so the whole network is down and nobody could work. And if someone destroy this center, the whole network is destroyed, and so on and so on. But or not destroyed, nobody could work. But here, if one node is switched off because of I don't know what, the others should work, and it's because every node is connected with others. Not everybody, but with many of them. So each node is not connected with everybody, but they have connection with more than one another nodes. And if we are talking about availability, you can see that this distributed system and blockchain technology is based on distributed network. The greatest availability of the system is based on distributed network, and blockchain technology is based on this architecture. Of course, distributed systems have some advantages and also disadvantages. Advantages are higher computing power, because there is no one server. Like here, there are a lot of servers and so on. You have relatively smaller costs, much bigger or higher reliability, and the ability to grow. Because if we are talking about this system. You cannot expand this system to 10,000 or even more nodes around the server, but here it's very natural to expand this architecture with more and more nodes. And of course, it's also some disadvantages, because you have some kind of overhead in coordination and communication. You have pretty big dependency on networks. The programs are more complex, and you are faced with so-called security issues. A special kind of these distributed systems are so-called peer-to-peer systems. In these systems, each node has its own computer resources. So every node, or each node, is a system which can survive for itself. They are connected with others, but they can work also in so-called offline mode. There is no central point of coordination, because everybody can compute their own programs, and of course each of them have some special kind of program for communication with others. Can you maybe do you have in your mind some example of this peer-to-peer model in everyday life? I'm perfectly sure that you already used such systems, but not blockchain. Would you tell me an example of such system, peer-to-peer? Maybe one? Just tell me. These are so-called torrent for exchange movies, for example. It's more familiar with you. This is a system of peer-to-peer. Computers are connected together. You have a small part of software named torrent, and you can exchange movies, files, and so on and so on. And this is so-called peer-to-peer model. Okay? Here is this peer-to-peer model has a special, something special inside. For example, if you still remember that many 10 years ago, we bought on the CD or LP music like this, and you had in one part people who bought these plates, and people and singers. And here was one organization or someone who worked with singers and with buyers. But later, after Napster, YouTube, torrents, and so on, we destroy this so-called economy model, how to sell something, because we started with peer-to-peer how to say, maybe economic model. And music industry changed a lot in the last 50, 40 years, really. And can you imagine that, for example, the bank industry or something else will be changed really drastically? For example, like in this music industry, that we don't need banks like today banks, that people will exchange money, loans and so on will go through these peer-to-peer systems. And we are already faced with this. So a lot of industry is faced with really big changes, and these changes will be supported with blockchain technology, because blockchain technology is based on peer-to-peer systems. So the whole industry will be changed. Industries, not just in this music industry, but the whole industry will be changed. And so-called this middleman, this authority in the middle here, will be disappeared. And this middle man, this authority, are banks, if you want, or a special kind of industry. This authority will be changed with peer-to-peer interactions and peer-to-peer systems, and blockchain technology is based on this peer-to-peer model. We will be faced with this intermediation between buyers and sellers, what is the most important. As you can see, especially now in COVID situation, we moved to internet to internet as a system to buy and to sell, and we don't need so many these big supermarkets and big buildings and so on, because everything is moved to work through internet, and later in a few years will be upgraded to blockchain technology. So, as we already said, this availability, because the system is based on distributed systems, peer-to-peer systems, availability is really high, is the highest what is possible, not today, but what is possible in not just what is possible, not just because of technology, but what is possible in general. And of course, if you have this computing power on all these nodes, maybe not all of them, but somehow in a lot of them, then integrity of information is much higher. Why? Because everybody should change information, what is the state about we will see what is the state of a system in one system and with another system, and so on and so on. So integrity, we will also see this in the future, is much higher. So, what is the biggest core problem in such systems? The core problem is that that everybody who is part of such a system should accept or recognize a central authority. And where is in blockchain this authority? In blockchain technology, this authority is on each node, which is part of the system. So you can believe that you cannot believe just in the one central authority, but you are faced with dispersion of this authority on the whole system. This is pretty the same if you have a problem and you need to go to the court. If you have one evidence because someone said something, because its authority is someone saw something, this is compared with this court where you are faced with one person or with a lot of persons which are claiming that some state is such as such. So the core problem, this trust, is we are faced with the dispersion of this trust. Of course, the whole system should be faced with so-called technical failures or malicious peers. These are dishonest peers which want to do something wrong, but it's not good. So the blockchain have really a lot of elements which are which made the proof that the information in the system are much more trusted than in other systems which are in use still today. Of course, and this is the last one, the term blockchain is used as a name of a data structure. It's also a name for an algorithm. It is the name for the whole suite of technologies, or just an umbrella term for purely distributed peer-to-peer systems with a common application area. So we want to know, if we are talking about blockchain technology, what we are talking about. Today, we are talking about all this, what is in this slide. The core problem is the ownership of something, whatever, or the goods, or the house, or whatever. So this ownership has three elements: identification of the owner, who you are; identification of the object being owned, what you are owner about; and of course you need to have some kind of this mapping between owner and the object. And we are doing this with so-called ledger in blockchain. These are a picture of a ledger, I don't know, 100 years ago or 50 years ago. And today, this ledger is one of the most important part of a blockchain, and this ledger is distributed on different nodes. And we are not faced with a central ledger, one, but this ledger is distributed. Ledger is one of another important part of blockchain technology, how to realize how to realize, yes, with blockchain technology, this ledger. And of course, we are using another technology. In very short, we will talk about cryptography a little bit later. Okay, and this is the last term in connection with blockchain technology, and this term is smart contracts. Smart contracts is a part of a code, a program code, which is part of one blockchain, and this block of code is also distributed across the network as data. It's a special way of data, and here are rules what to do with one input in the system. And according to this input, the system is doing something, because this is a code if then else. Treated the same like artificial intelligence, if you want, and this contract should be realized or should have some elements of artificial intelligence, and input is today in many cases is part of so-called Internet of Things. So input comes from some measurement or some data and so on. And according to this input, this data, these measurements, the code, which should have some elements of artificial intelligence, should do something automatically. So you don't need people. And according to these contracts, some people, some parties get some obligations, for example, payment or delivery, and so on, and so on, and so on, because this obligation should be executed. You probably, I'm not sure how you are familiar with this, maybe even a little bit lower level, but it's important in the blockchain technology. This is hashing data. Hash functions are transforming one input in a very simple manner in one output. This calculation is simple, fast, and it's simple. And it doesn't matter what is on the input, is the whole book or just one letter. The output is have the same length, the same the size of the output is the same. And from one input, you have a lot of different possibilities what to do with this hashing. And we will see later that this hash function is deterministic, provide hash values for any kind of data very quickly. It's easy calculation. It doesn't matter if this is a picture of or a letter or a story in one book. And the usage is one way. You can from the input calculate the output, but the vice versa is not possible. If you got the output, you can not calculate the input, or very, very hard. Okay, what shall we do with this hash function? You can calculate hash and hash of hash. You can input cut into different parts, and you are able to get different hashes. You should combine this, or first calculate one hash and from this input another hash, and so on and so on. And of course, from one input and the other input, you should calculate hash, and for both hashes you should calculate another hash. And this approach we are using in blockchain technology. You will see later. And here is how hash function works in a blockchain. Let me see how many minutes. Okay, still 15 minutes. Blockchain technology is based on a block. And each block here you can see is based on one input data. Usually, this input data is a document. You can see here is one document, another document, and so on and so on. And from or many documents, whatever. From this document or documents, you can calculate hash, and from this hash, two such hashes, you can calculate another hashes. And if we are talking about 4 different documents or set of documents, you can get like this motor tree here at the top, so-called top hash. Why this is important? Because each block has data, and of course so-called hash. This is top hash, it's here. And in each block you have the hash from previous block. You have timestamp and nonce. Okay, at the beginning we don't need to talk about this nonce. From this you can calculate another hash. So later, if someone wants to change something in this input data, and you can calculate once again this hash and so on, and because in each block you have hash and also previous hash from previous block, it's not possible to change something on such a way that this changes is hidden. So everybody knows that someone changed something. You cannot change here later in the time if you want. If we are talking about the time, and we have block, I don't know which number. You are not able to change in the history whatever. It's not possible. And because we have such a peer-to-peer model, and everybody is able to calculate these hashes. If someone change because, I don't know, because there's some problem or whatever, the others will say, okay, we do not agree with you because your hash is different than my hash or my hash and my hash. And what all these systems can do, they can just compare hashes, nothing else. And if everything is good, then hashes are the same, and you can believe that the data in this data is maybe ledger or some other documents was not changed, and this is the core of this blockchain technology. And we are talking about integrity of information because information cannot be changed. If we, in one moment, if we are working with one information, with one document, and this document cannot be changed in the history. Okay? I said for later we should talk about these nonce. You are familiar with this nonce? What is this? Anybody?
Number used only once. That is the number added to the blockchain to create the kind of complexity.
This is part of so-called mining. Usually, if you have private blockchain, you don't need this nonce. But someone said that this hash function should be the form of this hash function should be that the first five digits should be 0 or whatever, or here should be something else, and not on the first 5 places, maybe from the place 6 to 10 or whatever. You need to add to all this structure these nonce. This nonce means that you start with 1, 2, 3, 4, and you should calculate the hash function, and the shape of hash function should be such, for example, that the first 5 elements should be digit 0. This nonce is in use with digital money, but not everywhere. We already have some digital money without this nonce, and to calculate such a hash function that the shape is something like this means really a lot of calculations, because we need to calculate millions of for each block, millions of different hash functions with changing these nonce. In private blockchains, you don't need to do this, because you should have public blockchains or private blockchains. Private blockchains means that you have at least 2 companies, or I don't know, 10 companies and so on. And if we are talking with supply chain, usually we are faced not with public but with private blockchains. You will see later. Probably you don't you understand this cryptography and how to sign a document, and how to encrypt documents, And if we compound all these approaches, so this cryptography, this encryption, and blockchain technology based on peer-to-peer systems, and if we are talking about these blockchains, the philosophy of blockchains, then we are faced with CIO, which are the highest possible CIO. It means confidentiality, integrity, and availability of information. So only blockchain technology is a technology which are able to make us in today life, in today time, all these CIO on such a high level. Okay, still 3-4 slides. Here is blockchain in logistics industry and supply chain. And you can see that, for example, if you have a document or documented information from the farmer to the retailer and to the customer, nobody can change in this chain. Nobody is able to change something what was in the past, the data from the past, if we are working with blockchain technology. Because the nature of blockchain, we already see this, we already see here this, it's not possible to change. Because everybody is able to see that something was changed in these blocks. So you have so-called 100, almost 100% proof that all data are correct from the history, from the beginning, from this peak to the customer. Okay? Here is one example, and here you can see here are some questions, and if you say, is there a need for a shared common database? Shared and common database, because blockchain is based on shared common database. If you said yes, then you should go to another question. If you are multiple parties involved, not just one, I said at least 2 companies, but usually in a supply chain, we are faced with 10 to 100 parties. If they are possible that these parties are involved, some conflicts or mistrust to each other, what is possible in everyday life, then blockchain technology is the right technology. And still, let's go to another question. If you say, okay, we are faced with this, are there differences in the rules that govern these parties? Because one party, for example, this one is his processes are based on ISO standard. This one is based on another standard, and so on and so on. If you said yes, then we should ask another question: is there a need for objective, unchangeable log of records? Because blockchain technology is a technology which has objective and unchangeable log of records. And if we have rules, we talked about this, I said last, smart contracts. If we want to work with less people as possible. You know, there is not just a problem of the salaries of a lot of people, but here is a question of how to rule these transactions, because if people are working, people are making mistakes much more than if we are faced with the full automatization of the processes. Then blockchain technology is the right technology for you. Okay? Here is another example of safety business. If you want to have a safe business, the business should be based on blockchain technology because of CIA, as we already said. We are also faced with this if we are talking about drugs, the drugs industry and so on. And if we are faced with, we already talked about these smart contracts, then the possibility for random mistakes are really, really small, or we are not faced. This is not possible. Random mistakes are not possible. So I spent 1 hour. Please, it's time for questions. And I would like to say thank you for your attention. We are working how to use at our faculty, how to use this blockchain technology in everyday life. And here is also my email, and we should be in contact. Please.
So is there any question from the participants?
Yeah, please. Questions from everybody.
Yeah. Anybody is having any sort of query? Please feel free to ask Professor Boret. So I think, sir, nobody is having any sort of query, and you have provided your email also. So if they are any sort of query, they may be contacting you on your official mail ID, of course. And sir, myself, Mishra, we have been in touch on the, I think you might be remembering me.
Yeah.
Yeah.
And I can send you my presentation if you want. You should share it if you want with your colleagues.
Yes. Thanks a lot, sir. And
just let me know.
And we will be remaining associated with you for our future programs also. And we will like to have a very long association with yourself.
Yeah, thank you. I believe that.
Yes, sir. And on behalf of the Department of Mechanical Engineering, Maulana Azad National Institute of Technology, Bhopal, and my fellow coordinator, Dr. Vimlesh Kumar Soni, I give my sincere thanks to you that from your busy schedule, you just extracted an hour for us, and we are highly privileged, sir. And this is, as you are already knowing that he's also, Vimlesh Kumar Soni sir is also associate professor in mechanical engineering department. And he's also one of the coordinator or the main coordinator of this faculty development program. So thanks a lot, sir. And if
maybe
yes,
may I just ask you for each of you participants what do you think about this presentation. Maybe you should write because at the end, according to quality standards, we need to have some feedback, and maybe please write a sentence or two about this presentation, what you missed, what was not good, what was good, and so on and so on. So each of you, please write a message.
Definitely, sir. In the meanwhile, when you were presenting, the participants were sharing their feedback also, and definitely we will be sending you also. And you might be seeing on your screen also some of the participants are sending their feedback also. Vimlesh sir wants to say something.
Yeah, Professor, it's a nice time to listen to you for the whole session. I was extremely influenced by the input that you have presented to the whole group. Regarding feedback, we have a practice of collecting feedback of every session. Like now your session is over, there is a Google form circulated amongst the participants on certain 3-4 points. They are going to rate your session, your delivery, your subject content, the relevance of this topic to the course, and overall rating. So if you wish, we can share with you that rating straight away.
Please, yes.
Yeah, that we can do. That's a structured.
If you want, I will send you this presentation PDF or the presentation.
Yeah, we need that. We need that. We need that because we are going to make one single PDF file of all the presentations that the experts are using.
Okay, super.
So that would be a great contribution to all the participants in this program. So, Bharat, thank you very much for your session.
And thank you for listening, and thank you for attending.
Thanks a lot.
Thank you.
Thank you. Goodbye.
Okay.
Bye.
Okay. Goodbye. Thank you. So, all the participants, I will request you to kindly do the needful for the feedback as we were discussing. Your Google link is already sent to you. It is circulated in the chat box, and your WhatsApp group is also on the mail. So, you're requested to please fill that up immediately. And meanwhile, you have a little longer break this time. So, we'll be meeting back at 5 o'clock. Before that, if anything you want to tell, you can unmute and speak. We have some 5 to 10 minutes time to discuss. I have sent the complete list of the participants. Yeah, Bharat, yeah, you can leave the meeting. That's fine. Yeah, yes.
Yeah.
So you want to say anything? Yeah.
No, thank you. Goodbye.
Thank you. Namaste.
Namaste. Namaste from India, sir.
So right then, if not, no any suggestions because now our next lecture is from Professor B.E. Narkhede. He's from Maharashtra. He is associate professor at NITI and handling few consultancies, and he's going to talk on the lean thinking for productive systems. So how the lean thinking is relevant to productive systems. That's what is his topic. So we'll meet in that case at 5 o'clock. Thank you. All the three links are available on the WhatsApp group and mails. I received many WhatsApp saying that the link is not received. Minded, the moment link is created, it is naturally triggered to your mail. So you don't check your mail and you start writing WhatsApp. So my folded hand request is, please every day evening you are going to get mails for your next day's link. So before asking, check your mails kindly. Thank you.